Okay, so in the last unit you derived two algorithms for doing matrix vector multiply. One that went through the matrix from top to bottom and one that went through the matrix from bottom to top. But the cool thing about matrices is that you can slice and dice them in multiple ways. They have two dimensions, so you can slice vertically or horizontally. So let's see what alternative algorithms we can come up with. Well, let's go back to the example we started with. Here we have written out everything that needs to be computed. So notice that this right here you could think of as the first column times -1. Just scaling the first column by -1. Similarly, you can think of this right here as the second column multiplied by 2. And then the third column multiplied by -3. And notice that this here you can think of as a matrix multiply of a 3×1 matrix times a 1×1 matrix. But that is the same as saying scale that vector by the scalar -1. So whenever you do a vector times a scalar, that's the same as a scalar times a vector. And that's something you may have learned in linear algebra as well. So what does this mean? This means that we should be able to go through the matrix by columns. So, as a matter of fact, if you partition the matrix like this, sort of arbitrarily, notice that the left matrix times, we can't do times that vector because that's 2 columns times 3 elements. It doesn't work. So we need to partition it. The left matrix times this first part of the vector is exactly this computation right here. And then the right part of the matrix times the last part of the vector is exactly the computation that still remains. Okay? Or you can think of that as this is the first part and this is what remains. Okay, so how can we think about that? Well, let's go back to wanting to compute y is equal to a times x plus y. Okay? Which then of course becomes the post condition that looks like that. Except we have to put a hat on here to indicate the original contents of vector y. What this here suggests is that we should partition A into a left part and a right part. We should partition x into a top part and a bottom part. And we should leave y alone. And then the fact that you do this times that plus this times that over here suggests that linear algebra tells us that this is the same as the left part of A times x top plus the right part of A times x bottom plus y hat. And what is that? That is an alternative partition matrix expression. And then you take that partition matrix expression and you ask yourself the question, what loop invariance can I get from it? Go to it. Go derive me some more algorithms.